All right, hello everyone. Welcome to the HEIR meeting. So I will just go through the main things, and then I'll have like an RFC at the end to discuss. So we had 70 PRs merged since last month, which is exactly the same number as we had in the previous month, which is interesting. Um, and it starts with the layout system. So there was a bunch of work. I don't know if you guys remember the Coyote compiler from it was like S plus 23, I think. So their research lab has some grad students who are working on a next generation Coyote compiler, and they're doing it in HEIR. And so there were a bunch of changes to the layout or additional things to the layout system that involve because their layouts aren't quasi-affine. And so they have just sort of arbitrary permutations. And so they wanted support for the layout system for that. So I think these first two were related to that. Um, and then there's been a lot of work on Rotom, getting the layout representation and rolling support in. And I think there's a couple of more PRs that are waiting for my review. We have support for tricyclic batch matrix multiplication. There's an end-to-end test in there now that does correctness for that. This is related to our intern who is working on transformer support in HEIR. And it's loosely following the bicyclic and tricyclic, the Lawrence Lim's tricyclic paper. Um, and then I think on that note, if there's anybody who wants a decent first project, it would be adding support for the plain text matrix multiplication kernel for that, because that I believe that's the one that Cerium uses, or Cardamom. And it would be nice to have that kernel also in the compiler so we could try out different options. There's been a lot of discussion on ISL performance. The ISL code gen is very slow. ISL, um, uh, also ISL, what is it? Like quality checking is slow. Complements are slow. Like there's so many things that are slow in ISL. And I'm sort of collecting a list of examples that are slow, but I'm going to try and take back to like Tobias Cursor and people who are experts in ISL to see if there's anything we can do. But in the meantime, there's a bunch of small changes that we're making that are improving the compiler performance. I am trying to get a convolutional neural network to compile in under a second. The hot word detector model that I'm working on is compiling in 8 minutes right now, most of which is ISL slowness. So, okay, still working on it. And then I think that this was one of the earlier changes for the month, supporting chains of convolutions coming one after the other, because I think there was like a layout mismatch in between them.
This was basically to support like the striding propagation.
Yes, that's right. Um, okay, so we had some changes to the OpenFHE backend. I was going through some examples, and we just were not passing configuration flags through to the OpenFHE sub pipeline. So that was fixed. And I've been working on adding an emit-C based OpenFHE backend. So I have a basic OpenFHE to emit-C conversion pass. And now I'm working on, oh, sorry, I'm getting a little bit of echo from Mark. I'm going to mute you, Mark.
Yep, sorry.
Okay. um, so there, what was I saying? Oh dear, I'm getting someone's at my front door, ringing the doorbell. Okay, I'm going to have to ignore them, unfortunately. So the what was I saying? Oh, so I'm adding like a backend emit-C code generation, and it's a little bit complicated for OpenFHE. I have like a whatever 2000 line draft change that is in the works. But yeah, they are still at the door. Oh my gosh. Oscar, do you want to take over for just a few minutes? And then I'll come back.
Okay, wait, I guess I can talk briefly. Wait, which exact bullet point were you on? I got distracted. Were you on split
OpenFHE to
pre-processing?
MIDC.
Okay. Yeah, okay, we did OpenFHE to emit-C. Oh, and then also I guess the main big change here in the OpenFHE realm of things was that this is bufferized now, so there's memref emission from OpenFHE now. And then I guess there was a minor fix to the OpenFHE SCF if emitter. Um, Split preprocessing is on by default now, so you don't need to plus the like split preprocessing was true, and that's enabled by default now because now it should work with rolled loops for the kernel. So that was why it was disabled by default before, and that should be fixed now. I think I also had a fix just recently that will help with this too. On the like util side of the dialect lowerings, um, right. So now we have like there's more conversion utils. What else is interesting in here? Eric, I think, had a fix of mod down on key switch inner. There's a couple of small fixes. There was this rescale verifier fix as well. That was just a mismatch between what the expected scale was producing versus there was just two utilities that were calculating the expected scale, and those need to match now. All right, Jeremy, we are on optimizations now.
I'm back. Okay, great. Um, okay, so there's been some improvements to fusing lineage ops together. So one of them is fusing convolution plus pooling into a single convolution. One of them was improving the batch norm fusing into prior convolution and linear ops. Um, I don't know if there's any more improvements to the fusing that need to be done. And then let's see. There were some bug fixes around folding constant tensors. There was a bug with optimized relinearization. So our lazy relinearization pass will do lazy relinearization, but some backends will not support operations that are done lazily. In particular, OpenFHE does not support a plain text ciphertext addition that happens before relinearization. So we have to basically disable that, and then I was hoping the backend config could like be able to re-enable it for other backends that might support it, but I haven't checked if other backends support it. Okay, this was a decently big change. So now the polynomial dialect supports constant folding, I think in full generality, sorry, in full generality for x to the n plus 1 um, rings. So like the main CKKS ring. And now it will do constant folding for like any operation, and in particular NTTs. So if you have like a constant that gets NTT'd, it will NTT it in memory and spit out the constant um, at compile time. Um, okay, this was an embarrassing one. So I had done my looped baby step giant step thing, and then I forgot to hoist the baby steps out of the kernel. So it was redoing the baby steps in the inner loop over and over again, and that was causing it to be very slow. So that's fixed. And now we also support zero diagonal specification in the rolled baby step giant step. So in theory, the rolled baby step giant step for like convolution or mapmul should be as efficient as the unrolled ones now. Um, I'm still in the process of getting all of the example or all of the tests in our repository to work in the rolled form, so I can just turn it on by default. Um,
That's merged, right?
it's merged.
I think
Yep.
so. Okay.
I mean, in theory, there's nothing stopping us, but I think there's still some cases I'm running into where rolled programs will have failures in secret insert management because our management stuff is just still messy. Um, okay, and then there's a bug here that there were some attributes not being copied over when canonicalizing activation functions in the front end. Okay, for the CI, yes. Okay, I did a ton of work this month on making the build faster for everybody, hopefully. But now the hermetic LLVM toolchain is in, um, and that had some downstream effects. The first one is that we are no longer bundling OpenFHE with our Python wheels because what was the reason? Because OpenFHE requires like a newer ABI that is not supported in the CI build wheel. And so we said, okay, we're just not going to ship it with Python. Instead, what we're going to do is we're going to in our CI, we're going to build OpenFHE with CMake, pip install the front end, and then run tests, the front end tests just using PyTest. So now the CI has like a couple more steps in it after building and testing HEIR opt with Bazel, and then it does this separate step of just like standard installing OpenFHE. And that means that if you want to use the Python frontend with OpenFHE, you have to install OpenFHE yourself and like configure the front end to have the paths to the shared libraries. That's also a good thing, I think, because then it means that you can build it with OpenMP, and you don't have to worry about our like stupid thing where we can't build with OpenMP when we ship it with the Python wheel. So I think that's all around a good change. Um, Another change. Oh, there are a bunch of other little things like I just looked at like why the build was slow, and I found some places where it was slow for bad reasons, and then I went in and fixed them. So there's like a bunch of like LLVM optimizations that pull in a whole bunch of other dialects that we don't use for like GPU targets that we were compiling for no reason. Um, and then I think the big one is I enabled remote build execution. So now our CI builds and maintainer builds, like if you're a maintainer, you can ask me for a key and then you can get this yourself, where it will basically run, I think it gets access to how many cores? 100 cores, I think. So it's doing the builds distributed on the 100 cores remotely. And that cuts down the build to about 5 to 7 minutes, I think. Um, I also changed the default build mode to fast build, which helps over versus debug. Um, and then I made this change. So now we are enabling remote build execution from external forks. And the caveat there is that we have to bypass like GitHub's basic security thing that says you can't get access to API secrets when running a pull request from an external fork. And we guard against that by requiring a maintainer to press run CI on any external fork from someone who's like not a maintainer of HEIR. Um, and then now we have a little automated comment to a user's first interaction that says, come to our meetings and talk to us before we accept a PR from you. Um, Okay. In terms of in-progress PRs, we have a bunch of work going on the TPU backend. So there's this external cross project that needs a bunch of API updates, and then we have this emitter that is emitting the updated API. I think they've got it to the point where they can run like a sequence of matrix vector multiplications on the TPU, and it's faster than the hand-coded version that the cross maintainers wrote for like just their like handwritten baby step giant step optimization. So that's nice. But they're trying to get some bigger machine learning models going on there as well. Um, I was looking into bumping to Bazel 9.1. Apparently, there are a bunch of efficiency improvements in it, and we're blocked until one of our dependencies updates to the next version, which is scheduled to happen in September. Um, NTT consts, I think this is Eric Crockett's PR that will use the constant folding of polynomial dialect in the entity solver, because the entity solver will have constants. It will insert an entity at the very beginning. It will think of that as free, but that's not actually free unless we do constant folding. So I think that's what that PR is doing. Um, okay, there's more stuff about the Coyote work. Okay, there's this use copy on write for one-shot bufferize. I think I was a little bit confused by this PR. I think it's Mark's PR. Um, it looks like it has to do with the Cheddar backend. Could you say a little bit more about that, Mark?
Yes, I'm sorry for not getting back to you. I was away last week. So basically, there was this analysis phase that tries to figure out if it's okay to, if you know, to figure out if the slice needs to be copied or not. And this analysis phase was blowing up because I think many of the diagonals were coming from the same initial tensor, and the compile time was just exploding because of this. So
You're
that was
saying
the
the
pre-process.
bufferization compile time was slow,
Uh,
like the bufferization
ye-
pass was slow.
um, I'm trying to remember the exact name of the pass, but I think so, yes.
Okay, interesting.
But so it's a bit. I need to get back into it. So this was for the pre-processing, I think, and I'll run it again, see if it's still slow, and if it is, I'll get back to the PR.
I've noticed that pre-process bufferization can be slow in a lot of cases, and so I'm guessing that it looks like this PR is specializing to just the pre-processing functions, and so it can like make stronger assumptions about the structure of those, which I think is a good idea. Um, so
Okay,
yeah, I
now
think
that's good
probably
because
this is the right direction. I just was concerned. I think that there was. Is it still actually doing bufferization, or does it leave tensor operations in the output? You remember?
mm, I'm not
And
sure.
for some reason, I
I
looked at that
just
PR and I thought that it was still leaving some tensor ops in the output, and then I thought that like, okay, we don't want to have like mixed memref and tensor semantics in the same program. So that was my only concern. Um,
Yeah, to me, it felt a little bit hackish because I was kind of looking at steps and saying, "Oh, is it pre-processing? If it's pre-processing, I need to do something special." And so I felt like I was kind of not changing the thing at the right place. But
Yeah, maybe. I think that it's a reasonable thing to say that if we can assume more about a certain part of the program, then why not assume more, and then we can compile faster. But I would like to see like a concrete example of something that is slow when you just run the existing bufferization. Just like if you can come up with like a minimal test case that says like, okay, bufferize this, it takes 1 minute. Um, and then if you make the change in your PR, then it takes 1 second, right? Like that would be like a good example to have. Um,
yeah, let me flesh
I
out the
mean,
description.
I
Right.
mean,
Now
we
that you
have this
gave me
issue.
that, you tell me that it's kind of reasonable, I'll flesh it out and try
mhm.
to come up with a with an example.
I mean, we have a very similar problem, sort of a few steps down the pipeline when we generate C++, and then we want to compile a preprocessing function. And I think the same is true for Go. It's just with Go, we don't have a workaround. So here, the workaround from Mark's PI is to disable the like O of n squared analysis that bufferization usually does, essentially, I think. And so you get a linear scan through. And then for what we have to do in order to get the larger models that we output to, let's say, OpenFHE or Cheddar or something like that, to get them to compile through C++, we also have to run Clang at O0 to make sure it doesn't do any superlinear things on the functions, because basically the pre-processing function is just hilariously large by like most programming languages standards, right? So maybe the one of the
It should be looped,
solutions,
right? It should be looped. So why is it huge?
I don't think
because there's
it's
a
looped.
billion loop nests in there. Maybe this is
Okay.
because it's not looped. But I think even if you do have the loops, I'm not entirely sure it's that small a function. Once you start having, a lot of parameters that need and a lot of plaintext that need to be encoded.
Okay.
Um,
I mean, I think even if we unroll the FHE kernels, the preprocessing functions should still be looped. So okay, we can talk about this more offline. But
yeah,
yeah, you give an example, and then I can also bug some of the MLAR folks to see if there's some obvious thing we're doing wrong. Okay. Yeah. Okay. So there's this PR on adding support for lineage broadcasts. This is like a proper FHE kernel for a broadcast operation. I have not had the time to look at it. I think it's aging. I think it's 3 weeks old, and I've been just kind of ignoring it. This was Alice, one of our contributors, and I think we need to get to it at some point. Um, and then let's see, okay, this is, I think, one of the Rotom PRs I haven't reviewed yet on exposing babysit trans step into role semantics. This is one that I did review, and I think it's ready to go in. So we had a new contributor, Martin, who wants to add the Pulpy backend. And he's coming from like I think the ZK compilers space, and he just wanted to learn a bit more about MLAR. So he's going to add the emitter next, and then maybe soon we'll have a Pulpy backend. That would be cool. Um, now that we have hermetic LVM, we don't need the OpenMP flags anymore because the hermetic toolchain provides OpenMP. So I was going to remove the OpenMP gating, but then it caused the Mac OS build to fail for a reason that seems completely unrelated to OpenMP. And I don't know why. So I have to look into that a little bit more. And then these two orbit PRs, I think the first one went in this morning, I believe, and then the second one is the compression step that makes the ILP smaller. So I will probably review that hopefully today or tomorrow. There was a issue with the weights in Lynette. I think they were compressed somehow or compacted or folded together when now the compiler supports more and it doesn't need to be that way. And then, okay, so this one I think is so there's an issue in the OpenFFG backend since we don't bufferize it yet. It's actually not memory safe. And if you will tensor insert into some tensors, and because it's not doing copy on write, I think it will do some overriding. Not incorrectly. I don't remember exactly the problem, but there's an example in there that was failing. And I think this PR is actually the wrong thing to do, because what it does is it just changes the tensor insert op only to do a copy on write. And I think that we should just be bufferizing the whole OpenFFG backend. And I have this like 2009 PR that is doing that, but it's not clean and ready to go in yet. Okay, and then some notable recent issues. The CI slowness, that's the one that was leading to all the build buddy work. The CI's improved, but I think it could still do better. I've noticed that build buddy itself will be unreasonably slow for reasons I can't understand. Like it will compile everything fast, and then there will be like one step that is like generating the run files for one of our tests, and it will take like 3 minutes or 5 minutes by itself to do that one action. And so I think there might be some build buddy config that needs to be improved. So I will maybe look into that if I have time. Yeah, and I think most of these were addressed by PRs. Yeah, the out in place also has an issue, and I have a fix to the out in place that uses like a proper alias analysis, but I haven't had a chance to clean up and get it reviewed yet. So hopefully some of these will be fixed. Okay, so that I don't know if there's any questions or comments people want to have on the PRs that went in this week and the stuff we're working on. Before I go into, I'm going to have a little short presentation on the backend config. So I'll give a second for anyone to have any questions. Okay. Let's see. Slideshow. Cool. All right. So this is a little RFC. I don't know if we should like recommend that people do more things like this. It kind of slows down the process of developing features, but I think for the backend config, it's not as high a priority, but also very important to get right the first time. So I wanna make this one a little bit more formal. So the can I do this? Okay, it won't let me. Okay. So the problem, our HEIR config is very messy. We have, throughout the last few years of development, we have added a lot of assumptions about specific backends. An easy one to see is that the bootstrap depth required for Latigo and OpenFHE are different, but we hard code, I believe, the OpenFHE bootstrap depth when we're doing our level analysis and parameter selection. Um, we also have a bunch of backend config that gets passed via CLI flags. And that is to distinguish between the different backends. So we'll have something like a Latigo style rescale versus an OpenFHE style rescale that gets passed as a flag because that was the only way for us to distinguish.
Actually, we also have the module attributes now. Do we even use those? I guess we use those
Yes.
for a few things.
So we do those to check, like for CKKS versus BFE, we will do a different noise model, and we will check the module attribute to see, okay, which encryption scheme we're working on. But that is not a backend choice. That is a user choice of which scheme they'd like to compile to and which backend they would like to use. But once you've chosen a backend in a scheme, then we're still passing a bunch of flags that are supposed to be immutable based on that choice. But I think the part of the, yeah, so we also, in addition to these, we have some information that's persisted as module attributes. But in particular, propagating flags is like tedious and error prone. I think I just mentioned a few minutes ago that we had a case where I wasn't passing all the flags to the OpenFHE backend, so it was not configuring a bunch of things. And so it's just messy boilerplate code that we don't need. Um, Another thing is that we have a bunch of upcoming configs. So a good example is the orbit cost model, which is like a per level runtime latency for each FHE op, right? And currently involves pulling in a JSON file, doing some custom parsing and preprocessing, and we don't have like an obvious path to unify this with our other configs, right? And we don't want to have yet another way to pass configs. We also want to know like which backends have support for which higher level kernels, like a linear transform and eval Chebyshev, and that will allow us to either by default use the backend approved transform, right, or just make it easier for us to understand when we can do that and when we need to implement the kernel ourselves. Okay, so here's my proposal.
And I guess, sorry,
the
one of
oh,
the important cases that you don't list here, which is like the one that we just had in the overview, is like restrictions on what kind of like circuit that a backend will accept, right? So we had the example of OpenFHE not accepting non-relinearized ciphertext plus plaintext, right?
yes.
Cheddar is very picky about having the scale management be done a specific way it wants, right? So I think those are, I feel like those are by far the hardest ones, and they are the ones where we have the most hard-coded things or the most
Yep.
weird custom flags that you need to know about, right?
Yes.
And yeah, and I guess we don't even know all of them necessarily that we need to eventually expose.
Yes, very good. So okay, so my proposal is to use TableGen, so TableGen we use it right now for defining dialects and ops and sometimes patterns, and it has its upsides and downsides for that purpose. But the original thing that TableGen was designed for was to make backend configs. That's what it's used for in LLVM. And so I figured we could use it for a similar thing. So the idea is we will have a compilation target class that has a name and then a bunch of fields that correspond to the things that are configured for it. And then we can have subclasses for like the OpenFHE base, and then you can have subclasses or defs of that have like specifics for different flavors of OpenFHE, RNS, CKS. So the idea here would be, yeah, so for example, here's a Latigo one, you'd import the base target, and then you define Latigo's backend to have 16 levels consumed for its bootstrap. The this would come along with a binary called HEIR TableGen that will not only generate the struct that has all these fields in it, it will also generate helpers to register a new backend, and it will also provide overrides that you can call when you want to change something about the base backend config, like if you're testing something. And so this PR 2607 has like a proof of concept that does this for bootstrap levels consumed. And what it does is it will, so here's what some of the generated code looks like. So it will have a compilation target struct.h.inc, and then that will it will basically look at the base class for compilation target, look at all the fields, and then just convert them to, so there's a single source of truth for the definition of the struct. It will also have a helper function to apply an override to one of these things. So you can say, okay, I'd like to override bootstrap levels consumed to be 0, and it will validate that that is something you can actually do, right? That key that you're passing corresponds to a struct field, and then it will also give you a parser for if that so I will say in a minute, but the overrides can be persisted as module attributes, and then it will give you a way to parse those module attributes in a way that also has the same validation. It says only the allowed keys from the compilation target struct are things that you can override. So then this is now just C++ code that I wrote. there's a compilation target registry with some, it's basically a singleton for the registry, and then it has some stack methods to register a new target and to get a particular compilation target. And then it has validations for overrides. These are wrappers around the auto-generated code with some additional handling that didn't make sense to auto-generate. But like the basic thing that you would do in a pass is you will say, pull in the compilation target, include, get the module op for the IR that you're working with, get the target config for the module. If it failed, then you couldn't find the config for some reason, and then you can just access the struct field for the levels consumed and then go on and use it. So this is in the level analysis code in that PR. For overrides, so I found two places that I needed to do overrides, one of which was when the IR was modifiable by me. For some lit tests, I wanted to do this. So for example, there are a bunch of tests where since we don't have any, I think our default bootstrap levels consumed is 0 for a lot of these passes. And so I need that override to make the tests continue to work. The first one, I said, okay, well, I'll just put it on the module, and then I have this whole override thing that will, when it reads the backend, it will apply any overrides. And then the second one was when I actually have a shared MLIR across a bunch of different tests, and I only want to update one test. So I added a pass called apply config override that takes the key value pair and persists it as a module attribute for the later downstream pass to read. So that adds like an extra thing here that you can put in. Okay, I think I'm almost done. So I also have a register all backends helper that is called in HEIR opt to register all of the backends, similar to register all dialects. And then I have the annotate module pass actually validates that the backend that you're annotating the module with is registered as one of the backends in the registry. So it adds some more protection there. And yeah, I mentioned apply config override validates against the struct fields. And then I wanted to think a bit about the sort of cost modeling use case that we were talking about. And there I was thinking that we would have sort of a separate set of binaries and tools that do the job of constructing the cost model. Maybe you have a benchmarking binary that runs a bunch of operations at different levels and constructs a table of results. And then you have a second binary that takes that table of results and does whatever simplification or linear fitting or whatever is needed to turn it into a cost model that the compiler can use. And then that would output the table gen that you could copy and paste into the backend definition. And so that might, a cost model is like a big thing, right? So you might need a sub record and a substruct that would need to be generated here. But I think that's kind of all doable in this framework. It would just require a little bit more generating code for the cost model. But yeah, so that's I think that's my last slide. So any thoughts on this? And we'll go back to the table gen slide.
Yeah, one immediate one, which is I think what we need to do is have a backend be able to offer multiple backend options or something, right? Because my first thought was like, wait, but Bootstrap levels consumed depends on what I'm doing, right? I don't know if Latigo has a bunch of other Bootstrap options that consume different amounts of levels, but certainly some of the libraries do offer like low Bootstrap, high Bootstrap, right?
As far as I understand, OpenFHE supports two variations, one of which consumes like 18 levels and one consumes 22 levels, I think. And then so yeah, OpenFHE lets you say, okay, how many levels are consumed by encode and decode, but then they tell you should always use 4 for each.
Yeah. I think my point is slightly more general. Like I just picked this as an example of like, oh, I'm pretty sure I know a library that like gives you options here. I feel like the easy way to handle this is to just sort of make it so that in one compilation target, you sort of every one of the options becomes like, like you can pack a bunch of these options together and say, hey, here is my like flavor A of Latigo. Here's my flavor B of Latigo or something. That's probably easier because initially I was going to suggest, oh, we should figure out what like the range of all of these things need to be. I was like, oh no, it's probably much easier to just pretend from a compiler's perspective that there's 17 different flavors of OpenFHE.
Yes.
And like, even if that means that we can maybe see some, like TableGen is very good at doing like the cross product of things, right? So we can maybe think about making it easy to define the 17 different flavors if they're mostly just like the
Also,
cross product of things.
I think what you would do is you would have like a class for the OpenFHE base, right? And that would inherit from the
Yeah,
compilation target, put all the base things in there, and then you can do, I mean, you can do loops in TableGen, right? So you can
you could just iterate.
you can put a loop in there and do a cross product, or you can just have each record just override the like thing that's specific about the flavor. But I think you're right. I think like the encryption key technique is one of them. The key switching style is one of them. The rescaling style is one of them. And I think most of these are just like an enum of options.
Like, for example, one thing I would love to be able to support in here is like encrypting at the lowest level and then sort of forcing the circuit to start with a bootstrap. Which is like just such an easy thing to do if you're writing the thing by hand, and it like really helps you save like bandwidth. But it's not super obvious like how we would teach HEIR to do this. And I think, yeah, like if we sort of teach it that, hey, for this parameter set, this is sort of what happens, right? And then you sort of have the like, you would have this as a like backend flavor, right? Where like this backend flavor is you start at this. I don't know if it's a backend flavor necessarily, but yeah, like this is, I guess I have like a list of real world things we might want to do and have HEIR do. And I think what would be also be like, if other people have similar ones, I guess maybe for the TPU backend, right? See what sort of flavors there exist. And I think,
I think my big concern with this is what of these backend options will depend on the parameter choices, because the parameter choices are not immutable. And I think they have a big impact on, I mean, like certainly the parameter choice will have a big impact on, say, the cost model, right? Because if you're doing a larger N, your costs are going to be different. And I was talking about this a little bit with Oscar yesterday, that like for a cost model, all that really matters is the relative costs, not the absolute costs. But if the relative costs don't scale linearly, then you have like a different complication there. But I think for cost modeling, that's like kind of its own separate issue. You can work around that in various ways. But I want to, like, for example, if your parameter selection changed the number of bootstrap levels that were consumed by bootstrap, right? That would be, I think, a very difficult thing to record as a backend, right? And so maybe there's a way to have, I mean, if there's like a functional relationship that you could write down as like the, like, I don't know, it gets really complicated there. But I think trying to simplify it to like a small set of enums that can be, treated as if they were the only options is the way to go.
I think implicitly what this is, we first set the backend options, right? And I assume if we have like 17 flavors of OpenFHE, we pick one, right? And then we run the parameter, and then we run HEIR on it, right? And so in some sense, if you wanted to try out a few different versions, you'd have to like try them and just, we could write a loop around that if people wanted us to. But I think, so I guess the point is this, all the backend information needs to be like pre-parameter generation. Like ideally, I guess this should be heavily, I think like for me, it's like really this needs to inform the management like layer of HEIR. This is like the big one, right? And then slightly convert to ciphertext semantics in the sense of what we lower, but that's a fairly trivial one, right? I think, and so maybe one of the things we should start with is just enumerating all the toggles we actually currently have in the management layer, and which of those we actually plan to support fully, and which one are even like explored properly. Because so for Cheddar now, I think we do a weird thing where we like, what is it like? We don't use we don't emit adjust scale, but instead we forcibly like kill every single path in here that emits adjust scale, because we would get it wrong. We would like multiply with the scalar that's the wrong scale, because we only do like log n, like log scale. And instead we like change a bunch of the flags and also a bit of the code of the management path to be to only do everything with like level down, which like we can preserve and later like fix the scale for it, and then like the level comes from the emitter. So I think like that would be a really helpful like example, I guess, for us specifically, because we'd love to have the Cheddar backend like fully support this. Maybe for the TPU cross stuff, it would be good to also see like, is there anything there that changes? And the
That's a good question. I mean, I'm not too worried. I think from what I know about the cross stuff, it will be straightforward to incorporate it into this. Like, it's not doing anything super complicated in terms of, weird management stuff. So I'm not too worried about that. But it will definitely, like, I don't think that that will not have its own Chebyshev API. We will have to implement it. So I think it'll be more like that, like what kernels are supported.
yeah.
But yeah, so okay, are there any like big objections to having this sort of config situation? Because if not, I can merge this with just support for the bootstrap levels, and then I can just incrementally add things to it as they come along. And then we can even add like a Cheddar backend config, and we can start like poking around at what we need for that.
Yeah,
Okay.
I think that'll be really good.
And I guess everyone on YouTube who's watching, shout out.
I guess
to
you should
our
say, I think one of the
viewers.
things like I would love to
Send me
get
an email
Eric's.
or pop up via
Yeah, I was gonna say
Discord.
we should probably email these slides to Eric specifically as well. I know they're not currently using the like high level parts as much, I guess, but what they can foresee in terms of what backends, or like what flags their backend would have needed here.
Yeah. I will send an email out and I'll post it on Discord as well, for anyone to comment. And then I'll probably wait until like, I don't know, Monday or Tuesday or something before. Like, it's not like a high priority for me to get this merged immediately. So,
No.
yeah. Okay. Cool. That will be the plan then. Okay. Great. That was fun.
Actually, I have a slightly related question, sorry, which is we have a bunch of management things that are sort of what HEIR is currently doing, but then we also have Orbit being slowly upstream, which is awesome. How is that like currently interacting? Is it just an entirely different set of passes? Is it a bunch of flags, right?
It's an entirely different set of passes. And we have not incorporated into any pipelines yet. So I think that at some point when we think it's ready enough, we will make like a separate pipeline and then a flag that's like experimental use Orbit kind of thing, and until we're happy with it, and then switch over to it fully.
Yeah, because I was thinking like, how do I give the equivalent of the flags I'm currently providing to our pipeline? How do I give that to the future Orbit pipeline, right? So
yeah, I'm not actually sure what configuration options Orbit supports right now, and how much it is hard coded to the Latigo backend. Edward.
I think most of it is pretty much hard coded to the Latigo backend.
Okay.
So I don't know if there's that many configuration support. It's just, I think the only thing would probably just be like you can probably change your bootstrapping levels, and that's probably it.
I think the nice thing about Orbit, I mean, like ILPs are very easy to add configuration options to, because you add a configuration option that changes some constraint construction or adds or drops some constraints. Like it was very easy for me to add the lazy relinearization fix, because you just say, oh, just add this new constraint if this thing is not supported. So very, very straightforward, I think. But yeah, it would be nice to, maybe you guys should powwow and come up with a list of things that you would need, or yeah, because I think, yeah.
I'll probably upstream. I'll get back to the dialect and the emitter things, but then I'm aiming to actually have a PR for the like beefy part of the backend that actually does the management like changes. Probably a draft PR, just so that we can look at like, hey, where did I have to take a hacksaw to management, and then we can see and maybe look at that and see. It's not as bad as I initially thought it was, right? It's a lot less ugly than it used to be. So
I've done some work on it, yeah, but it's still like not correct. Like there's still lots of bugs. Like I noticed, if you like tensor insert a ciphertext into a tensor of ciphertexts, it just completely ignores the level constraints there. And so it's like, what do you do in that case? Do you level reduce everything in the tensor? Do you bootstrap the thing you're inserting? Like I'm not actually sure what to do in this situation, but
I don't know if Ed wants to answer this on the record, but is Orbit performant enough that we can eventually just make it the management layer?
I want it to be.
Yeah, because I think that might be the answer, right? Because then all of these things just become, here's another constraint, right? And then it also becomes really easy for people to understand what is going on in management, right?
Yeah, I think that is the eventual design goal. So I think
Yeah.
it should be able to handle that in the future.
And I think it is still on order of like 6 minutes or so for like all the examples they tested,
Yes.
which is not terrible. But my
Which is
goal of
about as long as it takes us to figure out that one convolution needs to be diagonalized, right?
I was gonna say, well,
Or
I was
used
gonna
to
say
be.
my goal of compiling a convolutional network in 1 second is gonna evaporate if it needs 6 minutes to do ciphertext management placement. But it's probably worth it in the end. Um,
Yeah.
but yeah, I mean, we'll look into it. Okay, so the other two topics, one is the Torch MLAR stuff. So I am basically done with all of the feature work on Torch MLAR. And it's just waiting for the maintainers to review. We've gone through a couple of rounds of review, both on the Python release and on the annotation support. Alex, I don't know if you guys have seen the annotation work, and if you have any opinions on whether it's better or worse than the thing that you had done. I don't know if
Almost
you want me
certainly going to
to.
be better, but I'm literally typing an issue into our internal tracker to try this out.
Okay, well, I can show a little bit about what it looks like. So here's like the simplest example is there's a new can you guys see this? Well, okay. So there's a new Torch MLR extras annotate, and it has and this is like a Torch op called annotate and pass through. And then what you do, I mean, I might give it a shorter name, but what you do is you just put it inside of your forward pass, any place you want an annotation. And then you you give it to a graph input that will correspond to an arg attribute on the func. And then if you give it to any other thing, that will correspond to an SSA value or an attribute on the op that defines the SSA value. So this would be like for domain lower bound, domain upper bound, and then this would, I don't know what we would use it for func attributes, but I just said, okay, why not make it complete and have you be able to annotate anything? And so when you do this, I don't have the output IR for this particular example in the description, but that's basically the ergonomics of how you would use it. And so then you have to be able to take this and put in here the actual computed results of your forward pass, which is, I think, a little bit weird. I guess I'm not sure exactly how we would do that, but in the very worst case, you can run it to train, get the outputs, and then just manually put them back in here in your forward pass and run it again for export.
Yeah, so I think one of the reasons why we did the hacky thing is because we want to not have people have to change their like
That's true.
PyTorch model.py
Oh,
file,
I
right?
don't.
And so that
Mm,
that was like one of the design goals is that like you have an import model from model.py, right? That just doesn't know FHE is a thing. Maybe it's an FHE friendly-ish model, but it's like it doesn't. But I think like I don't know if you want to like put these in
but so
the
I mean,
like
this is
actual
this is Python.
Python.
This is Python, right? So you can take an existing torch model,
Yeah.
and then you can have a function that goes in
Uh,
and dissects it and adds these annotate and pass through things in all the right places, and then produces as output the annotated torch model. I think that would be a reasonable user behavior.
Yeah, I think that's probably feasible. I think maybe I'll add this to the issue to try out if we can sort of automate this process nicely.
I mean, we can also add this to the HEIR Python package, right? Like, I think that would be a reasonable
Yeah.
thing to do. Or we could have like a HEIR-torch package that just supports this. But yeah, so I think that is the right way to go. At least I think this is what the maintainers are happiest with, versus
Yeah, and this
injecting
seems
something.
sensible. Yeah.
Yeah. And it was actually very nice to implement. So what I did, there's some 1,000 different lowering patterns in Torch MLIR, like for lowering every single different op to all the different backends. And then my solution for doing for propagating all of the attributes through the IR was to create just a pattern that has a listener on it that wraps every other pattern. That basically says, okay, anytime any operation is changed, copy designated attributes from the old op to the new op. So it was actually like a relatively small code change to get this listener to like propagate all of the attributes all through to every single backend. So in theory, this would also work because this Torch MLR also goes to Stable HLO and also goes to TOSA, I think. And so in theory, that means we could use this same thing for other. I don't know why we'd want to use stable HLO and TOSA, but point is that it's fully supported in those use cases as well. But okay, so there's that. Okay, that's I think the last topic we had was that I think Asra had gotten the Linnet convolutional network to compile and produce correct results. So that's nice. And then I think she's still working on like the performance of the compiled model. But yeah, so that's like I guess a long time coming. All the improvements to like convolution support. But yeah, okay. So we've got 5 minutes left. I will leave the floor open for any other discussion topics people have. Okay, all right. I'll stop the recording here. Thanks everyone, and we can take offline, off recording questions.